Move. Just point, just point. Okay, I see a lot of points. Our trend would maybe in this direction, and a couple people pointing kind of down, right? Why would these rocks, if they're up on a mountain, want to move down?
Well, the rocks,
There's one force that I'm looking for.
well, a rock might move in and take it out and move down it.
Maybe, maybe. What I'm looking for is a force of,
Wind.
it pushes down on us all the time.
Wind?
No, it's actually gravity. So gravity acts on us, it also acts on these rocks. So if you're way high up on the mountain, gravity is slowly going to be pushing those rocks down. And as this rock travels downhill, bloop, 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 it falls and it bumps into other rocks, right? And then it gets really cold and maybe a little piece of it chips off. It goes through these processes of erosion and weathering. And it breaks these rocks down into smaller and smaller pieces. So it's falling, and it gets smaller, right? Then maybe it lands in our river and it gets even smaller. It travels through the river, it's being eroded and weathered that whole way, and eventually it makes it to our lake. By the time it got to the lake, a rock this big may only be as big as maybe one of these white crystals in it. It could have a lot of weathering to break it down into smaller and smaller pieces. So here's another question for you. If you take a rock, throw it in the lake, what happens? Yeah, it sinks. It falls down to the bottom. So here's a rock that started on top of the mountain. Right? It weathered and eroded, it got really small. Now it's at the bottom of a lake. It's like, all right, this is pretty cool. It's kind of dark. There's lots of like stuff floating around on me. Then all of a sudden it notices that more and more stuff is coming down. And it's starting to be covered. And it's covered by a lot of stuff, and there's a lot of pressure pushing down on this rock, right? So I want you to take your two little dough balls, okay? And you're gonna make a nice little ice cream cone. So we're modeling, here's our two small igneous rocks, right? That are buried in this lake. And then over time, thousands, millions of years, you start applying pressure. So you push them, you're pushing them together. Pushing, 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 and you should get a nice, kind of weird looking sandwich hamburger thing, right? So you should be able to tell that there's two rocks in there, right? The different colors, right? They're not so squished that you can't tell them apart. But is it really easy to pull these rocks apart? No, they're kind of stuck together. So if we started with two pieces and we applied lots and lots of pressure over time, now these pieces are stuck together. Did we form a new rock? Yeah. Who has an idea of what type of rock, igneous, metamorphic, sedimentary, we might have formed? I'd like to hear from some new voices. I know you all have opinions, ideas. Yeah, you got it. I know you. You forgot? Okay. Let's hear it.
That kind of rock.
This kind of rock? Who can help them out? What kind of rock was this?
Sedimentary.
Yeah, sedimentary rock. So we've gone through a transformation. Our igneous rock has become a new type of rock. It's now a sedimentary rock. And here's a funny thing. This lake, right? It once was a lake. It's actually been totally filled in. And more rocks keep pushing it up. It's like this rock is going deeper into the earth. And when it gets really deep down there, it gets super hot, thousands of degrees, right? And then the pressure is huge. There's just tons and tons of pressure to where this rock, our sedimentary rock, now starts to deform. So everybody, take your Play-Doh, fold it over, and then squish it back into a ball.